This video explains the two most widely used network troubleshooting commands. These commands are ping and traceroute. The ping command allows you to test connectivity between two network devices. The traceroute command displays the path that data packets take to reach their destination. These commands are universal. All operating systems support these commands. You can use these commands on any platform and operating system. However, there is a slight difference between the term used to refer to the traceroute command. Windows-based systems use the truncated term while Linux-based systems use the complete word. This difference does not affect the command's functionality. It works similarly on all platforms. The ping command is the first command administrators use to troubleshoot connectivity-related issues. This command accepts the destination computer's name or IP address as the argument. It sends dummy data packets to the destination device. These dummy data packets are referred to as payloads, and the messages they carry are known as echo messages. If the destination device is up, it replies to echo messages. The source device receives these echo messages and verifies the connectivity. If not, it indicates a connectivity issue. This issue can occur at any point along the path. To figure out the exact location, you can send echo messages to devices placed along the path. Send echo messages to the first device. If it replies, send them the second device. Repeat this process until you get the non-functional device. A non-functional device does not respond to echo messages. There can be many reasons for this. For example, it may be faulty, protected by a firewall, or configured by an administrator not to respond to ping echo messages. Once you identify the non-responsive device, you can take several steps to resolve the issue. Administrators mainly use the ping command to test connectivity from the loopback interface, the default gateway, the DNS service, and the remote host. Let us understand these tests and their purposes. Open the command prompt or a terminal if you are on a Linux system. Run the ping command. Specify the IP address 127.0.0.1 as the argument. If it receives replies, it verifies that the TCP/IP protocol suite is functional on the system. The TCP/IP protocol suite provides all the protocols and things systems need to communicate on a network. A system can communicate with another system only if it has a functional TCP/IP suite. The ICMP protocol is part of this suite. It provides many tools and commands for testing and troubleshooting, including ping and traceroute. It reserves a range of IP addresses for testing the protocol suite on the host system. These addresses are called loopback addresses. Loopback addresses allow you to test and verify the TCP/IP suite on the host system. If the source and destination devices are in different IP subnets, the default gateway becomes an essential point in the communication path. It takes data from the source device and forwards it to the destination device or the device connected to the destination device. When you purchase an internet connection, the ISP gives you a modem or router. This router contains an IP address that serves as the default gateway for all hosts connected to it. You can use the ipconfig command on a Windows system and the IP address show command on a Linux system to view the IP configuration of the local system. In the output, the first interface is the loopback interface. It is a virtual interface. It does not connect the system to any external device or host. However, it uses the first IP address from the loopback address range and remains always up. It allows you to test the TCP/IP protocol stacks on a standalone system. After the loopback interface, it lists all physical interfaces. It uses physical interfaces to connect external devices and systems. Each interface needs a unique IP configuration to communicate with other systems in the network. There are three ways to assign IP configurations: automatic, manual, and DHCP. In the automatic method, the system automatically picks an unused IP address from a predefined IP range and uses it to communicate with other systems on the local network. In the manual method, you manually assign an IP configuration to each interface. In the third method, a DHCP-enabled device provides IP configuration to all devices. The modem or router you get from the ISP includes this service. It provides an IP configuration to all connected devices. This IP configuration consists of the modem's IP address as the default gateway. The IP route show command shows this IP address. It is the IP address of the modem. It allows the system to access the internet. Send ping requests to it. If the system gets replies, it verifies connectivity between the system and the gateway device. The third important use of the ping command is testing the DNS service. The DNS service translates names into IP addresses and IP addresses into names. The IP configuration the system receives from the modem includes the IP address of the DNS server. Linux automatically adds this IP to the /etc/resolve.conference file. To know whether the DNS service is running, you can send ping requests to the IP address listed in this file or a host available on the network. On this system, the DNS server's IP address and the default gateway's IP address are the same. It usually happens when the system receives the IP configuration from the modem. Since the DNS server's IP address and the default gateway's IP address are the same, and we have already tested connectivity with the gateway, let us send ping requests to a host available on the internet. The ping command first connects to the DNS server and translates the name into the IP address, and then sends echo messages to the translated IP address. If the specified host is not available or the service is down, it returns an error indicating that the host or the service is unknown. If the host is available and up, it replies to the ping messages. In the output, this is the host or service name at the remote system. It is the IP address of the remote system. It is the size of the data packets this system sends. It is the size of the data packets the remote system uses to reply. It is the sequence number of the data packet. It allows you to track data packets exchanged between both systems. It is the time taken by the data packet in the path. It is the TTL value. It defines the maximum time a packet can live. When we terminate the testing, it prints the test results. In this test, it sent 3 data packets and received replies for all. The ping command supports many options. Let us understand some essential options. There are 2 versions of IP, IP4 and IP6. By default, it uses IP6 to send echo requests. To send ping requests on IP4, use the -4 option. It forces the ping command to use version 4 for testing. Similarly, we can use the -6 option to force the ping command to use IP6. By default, it sends ping requests until we stop it. To send a specific number of packets, use the C option and specify the number of packets. For example, this command sends 4 packets. The default size of data packets it sends is 56 bytes. To use a custom size, use the S option. For example, this command sends data packets of 100 bytes. Similarly, we can change the interval between 2 consecutive packets. For example, let us set it to 5 seconds. Now, it will wait for 5 seconds after sending a data packet before sending another data packet. The traceroute command works similarly to the ping command. However, instead of sending echo messages directly to the destination device, it sends them to each router between the source and destination. In the output, it is a hop number. It indicates the sequence of routers the packet passes through, starting from 1. For each hop, traceroute sends 3 echo messages and displays the time it takes for each message to travel to that hop and back. These times are in milliseconds. It is the IP address or the hostname of the router. If you see asterisks for a hop, it means the router at that hop did not respond to the echo messages within the allotted time. The possible reasons for it could be packet filtering and network congestion. Finally, let us understand the response types you may get in the output of both commands. In the output of the ping command, you can see 4 types of responses. A successful response indicates that the target host received the echo request and sent back an echo reply. A request timed out message means no echo reply was received within the default timeout period. It indicates that either the target host is offline or a firewall is blocking the ICMP traffic. A destination host unreachable message indicates that the local system or an intermediate router cannot find a path to the destination host. An unknown host error means the hostname you entered could not be resolved to an IP address, indicating an issue with the DNS service. The output of the traceroute command has 3 possible responses. A complete trace till the destination. It indicates all routers in the path are up and functional. A request timed out message indicates that no response was received from a specific hop within the timeout period. A destination net unreachable message indicates that the packets could not find a route to the destination. It generally occurs due to a routing issue or an incorrect destination address. That's all for this video. In this video, we learned about the ping and traceroute commands. If you have any comments or suggestions about this video, please share them in the comments section.